1 times 10 raised to power minus 6. I is equals to 22 over 7 times 9 times 35 all over 11 times 10, which is equals to 9 meters. The length L of concentric wire is equals to 9 meters. Example 2. A galvanometer of resistance 50 ohms, which gives a full-scale deflection for 1 milliamp, is to be adapted to measure current of up to 5 amp. A. Calculate the resistance of the resistor required. B. If the resistor is made of a material of cross-sectional area 4 times 10 raised to power minus 4 cm cube and the resistivity 2 times 10 raised to power minus 6 ohms, calculate its length. Solution. Rho is equal to capital R times capital A all over L, which is equal to 3 times 0.004 cm cube all over 2 times 10 cm, which gives us 0.60 ohm cm. Example 4. An electric heating element made from nichrome wire of cross-sectional area 0.5 mm squared has a resistance length of wire required if the resistivity of the nichrome is 5.5. Solution. Rho is equal to capital R times capital A all over L, which is equal to 3 times 0.004 cm cube all over 2 times 10 cm, which gives us 0.60 ohm cm. Example 4. An electric heating element made from nichrome wire of cross-sectional area 0.5 mm squared area capital A is equals to 0.5 mm squared, which equals to 0.5 times 10 raised to power minus 3 squared meter squared, which equals to 0.50 times 10 raised to power minus 6 meter squared. From capital R equals to rho L all over A. L is equals to capital R times capital A all over rho, which equals to 2.20 times 0.50 times 10 raised to power minus 6 all over 5.5 times 10 raised to power minus 7, which will give us 2 meters. Conductivity. Conductivity delta is the inverse of resistivity. That is, conductivity is equals to 1 over resistivity, which is equals to conductivity. The unit is per ohms per meter. Electrical measurement. 1. Measurement of potential difference capital V using potentiometer. Since the wire is of uniform cross section, the resistance per unit length is constant. That is, capital R is proportional to I for a constant current I. V, capital V equals IR, which equals to KI. 2. Comparing two low resistance using potentiometer. Figure 427 shows a diagram of comparing the resistance using potentiometer. If a balance L1 is obtained with X connected to A and Y to B, and a balance L2 when X is connected to B and Y to C, then VAB over VBC equals to I1 over I2, which equals to R1 over R2. Comparison of EMF using potentiometer. Figure 428 compares EMF of cells At a balance point, the EMF capital E is proportional to the balance length L. Therefore, if a cell of EMF E1 gives a balance length L1 and a cell of EMF E2 gives a balance length L2, since E1 is equal to KL1 and E2 is equal to KL2, we have that E1 over E2 equals to I1 over I2. Example 1. In the potentiometer circuit above, the cell E1 has EMF of 0.8 volts and the balance length for cell E1 and E2 are 40 cm and 60 cm respectively. What is the EMF of the cell E2? Solution. E1 over E2 equals to L1 over L2. 0.8 over E2 is equals to 40 over 60. Making E2 the subject of the formula, we now have 0.8 times 60 all over 40, which equals to 1.2 volts. For measurement of resistance, Wheatstone bridge. The most convenient and accurate way of measuring resistance over a range of widely different values is given by means of Wheatstone bridge. Figure 4.29 Wheatstone bridge. It consists of 4 resistors R1, R2, R3 and R4 connected as shown above. When current from battery is passed and one of the resistors is varied, a balance point may be reached. This means that no current flows through the galvanometer. It follows that R1 over R2 equals R3 over R4. Example 2. What is the value of R4 in figure 4.29 when G shows no deflection in the circuit shown above? Solution. When G shows no deflection, R1 over R2 is equals to R3 over R4. 40 over 60 is equals to 30 over R4. R4 is equals to 30 times 60 all over 40, which is equals to 45 ohms. Figure 430A, the meter bridge. At balance point C, there is no deflection. The sensitivity galvanometer G, if L1 is equal to length AC and L2 is equal to length BC, we have that S over R is equals to L1 over L2, or S over R is equals to L over 100 minus L. Example 3. When a non-standard resistance of 2.0 ohm is connected to the 0.0 cm end of the meter bridge, the balance point is found to be at 55.0 cm. What is the value of the unknown resistor? Solution. At balance point, L1 over L2 is equal to R1 over R2, but L1 is equal to 55.0 cm. L2 is equal to, in bracket, 200 minus 55, which is equal to 45 cm. R1 is 2.0 ohms and R2 is unknown. 35 over 45 is equal to 200 over R2. Therefore, R2 is equal to 2 times 45 all over 35, which is equal to 2.57 ohms. Example 4. Looking at figure 430B, in an meter bridge arrangement, there is a zero deflection of galvanometer when the L1 is equal to 40 cm as shown in figure 430B above. Calculate the value of the resistance R. Solution. At zero deflection of galvanometer, L1 over L2 is equal to 10 over R. 40 all over 100 minus 40 is equal to 10 over capital R. 40 over 60 is equal to 10 over capital R. Therefore, R is equal to 10 times 60 over 40, which equals to 15 ohms. Electrical